This is Dr. Thomas, math instructor at Lawson State Community College, and in this presentation I'm going to show you how to graph linear equations. So there are three different ways to graph equations. The first way is that you can use a t-table, or you can use the slope-intercept form to plot the y-intercept and then run from that y-intercept, or you can just use the x and y-intercepts. All of these will give you points that you can draw a line through. So the goal is to determine which method is the easiest for you to use for that particular problem. So there are three different ways to graph, but you decide on which way is best for you. Now here's your cheat sheet. If the equation is already in standard form is ax plus by equals c, then graph using x and y intercepts. If the equation is in slope-intercept form, meaning y equals mx plus b, then graph using slope and intercept or a t-table, whichever is easiest for you. Next, if the equation is in neither form, rewrite the equation in the form you prefer. I prefer the slope-intercept form, so that's what I will be using in this presentation. Let's look at this. Graph y equals negative 1/3 x plus 2. Which graphing method do you think is the easiest? Well, it's already in slope-intercept form because y is on one side by itself. Slope-intercept form is y equals mx plus b. Here, your b is 2. Your b is 2 and your m is negative 1/3. M is your slope. So the first thing you would do is graph the y-intercept. The y-intercept is b, which is 2. So says start here, so notice that 0, 2 is already plotted. Now what would you do from 0, 2? What you should do is go down 1 because of the negative 1 for rise, and go to the right 3 for run. Some people, however, would do the reverse. What they would do, they may decide that they will rise 1 and run negative 3. It doesn't matter because both 1 over negative 3 or negative 1 over 3 is equivalent to negative 1/3. So you could potentially go up 1 and then go left 3 units. You choose. You decide. Alright, you can repeat this again, and you will go up 1 to the left 3, or as I've said, I normally go down 1 and over to the right 3, but you're still going to end up on the same line. Graph negative 2x plus 3y equals 12. Which graphing method is easiest? Because this is, you have your x and y already on the same side and you have 12 on the other side, then Go ahead and plug in zeros for x and then plug in a 0 for y to find your x and y intercepts. So, to find your x-intercept, we're going to let y equal 0. If you substitute 0 in for y, you're going to get x equals -6. So your x-intercept is -6, 0. To find your y-intercept, let x equal 0. When you plug that in, of course, you're going to get 3y equals 12, which is y equals 4. So your y-intercept is 0, 4. These 2 points are your intercepts. Because they are 2 points and you only need 2 points to graph a line, then you can just plot those 2 points and draw a line. Voila, you're done. In this case, which method is easiest to graph? Because it's in this form where x and y is on the same side, and to avoid solving for y, you could use which method? The third method here, the x and y intercepts. Plug in zeros. So let's do that. What is the x-intercept? So to find the x-intercept, again, let y equal 0. Then you have -3x plus 6 times 0 equals 2. 6 times 0 is 0. So you have -3x equals 2. Divide by -3. X equals -2/3. So what is the x-intercept? It is -2/3, comma 0. Now let's do the y-intercept. For the y-intercept, let's let x equal 0. So -3 times 0 plus 6y equals 2. That goes away. 6y equals 2. Divide by 6. 6 is canceled. Y equals, what is the answer here? Not 3. The answer is what? So think about it. Think about it. You should divide 2 into 2, which is 1. 2 into 6, which is 3, is 1/3. Therefore, the y-intercept is 0, 1/3. And the x-intercept is -2/3, 0. Do not put these two numbers together, the -2/3 and 1/3, as if it's a point. They are two separate points. Okay, which is the graph of y equals x plus 2? Now, first, what you could do is you could do a t-table. You could do the method of rise run, or you could do x and y intercepts. It really doesn't matter. Let's choose x and y intercepts because I'm noticing from the options that they are giving us that the lines are crossing the x and y axis. So that means that these are intercepts because the points are intercepting the axis, the x and y axis. So how do you find the x-intercept again? We're going to let y equal 0. So 0 equals x plus 2. Then how do you solve for x? You will subtract 2 and get x equals -2. So which one of these has -2, 0 as a point? Alright, -2, 0. So this is -2, 0 here. Okay, 2 is out because it doesn't have -2, 0. 3 is out because it doesn't have -2, 0. But option 4 has -2, 0 as well. So let's find the y-intercept. Let's let x equal 0. So y equals 0 plus 2. Y equals 2. Therefore, the y-intercept is 0, 2. Now, which one out of option 1 and option 4 has 0, 2 as a point? Alright, number 1 has 0, -2 as a point. So 1 is out. And let's confirm that this is 0, 2. Yes, this is 0, 2. So the answer is option number 4. Now, let's do some problems. Let's graph y equals 3x minus 2. Now, which method would you like to use? So first, let me start off by showing you the y-intercept and then rise-run method. So what is the y-intercept? Since this is already in slope-intercept form here, this y equals 3x minus 2 is already in slope-intercept form. The y-intercept is the b portion. So slope-intercept form again is y equals mx plus b. Is in that form because y is on one side. The b is -2. Therefore, the y-intercept is 0, -2. Alright, what is the slope here? The slope is the number in front of x, so it's 3. And if we're going to do rise or run, rise over run, then 3 is equivalent to 3 over 1. So we will rise 3 units and run 1 unit. Okay, let's get started. So first, plot the y-intercept. Where should you go to plot 0, -2? 0, you go left or right for x. -2, you will go up or down. So for 0, we will not go left or right because it says go 0 units for left or right. But for -2, we will go down so many units. Okay, we will go down 2 units in this case. So let me put some little markings here, and let me plot the 0, -2. So this is 0, -2 here. From the y-intercept, you should rise 3. So rise 3 units, 1, 2, 3, and run 1 unit. So we'll end up right here. And you will plot. I need to clear that. Alright. And attempt to draw a straight line if I can. Right there. Alright. And then I'm going to attempt to draw some arrows at the end because this line is continuous. It keeps going on forever. Alright, let's try another one. Let's graph y equals 1/2 x plus 3. So again, this is in slope-intercept form already. And again, you can use the method in which you find the y-intercept and then rise run. So the y-intercept here is the 3 and it's written 0, 3. Then M here is 1 over 2. So your rise, we will rise 1 and run 2. Alright, so the first thing you do is plot the y-intercept 0, 3. So where to go to plot that? From the origin you will go up 3. Then you will rise 1. So let me make this another one. Rise 1. And you will go over 2. Because it says in the denominator 2. Run 2. So again, let me attempt to put a straight line through here. And don't forget to put arrows at the end. Alright, so that is the graph of y equals 1/2 x plus 3. Let's try another one. What about y equals -3/2 x plus 3? Alright, so this is in y-intercept form already. So what you could do to graph this is find the y-intercept. Again, it is 0, 3. And from there, you will rise, run. Your slope is -3 over 2, which is the same thing as rise over run. So let's draw coordinate axis here. So first plot 0, 3. Alright, 0, 3 is here. Then it says -3 over 2. So what you can do, instead of rising, you can just go down 3. Alright, so because it's negative, we can go down 3 units from the y-intercept. 1, 2, 3, and go to the right 2 to run 2. Then we'll connect. There you go. Okay. Now here, notice that this is still slope-intercept form because the y is on one side by itself. Now what you could do, if you don't like the fact that it doesn't have a b, is you can just replace that b with +0 because these are equivalent to each other. Correct? Yes. So you can still do the y-intercept. The y-intercept here in this case is 0, 0. Okay, and then the slope is -2, but since we need a rise over run, we want to make this a fraction. Just divide -2 by +1. Excuse me. Alright. So let's plot 0, 0 right there. And what would you do from there? Okay. Since we have a rise of -2, let's go down 2 because it's negative and go to the right 1. And then draw your line and put your arrows at the end, and you're done. Notice as well, if your slope is negative, then your line should be going down to the right on the right side. If your slope was positive, your line would go up on the right side. or 4. What to do here? Now, since this is in standard form, what was suggested in the PowerPoint is that you go ahead and find the x and y intercepts. Alright, so to find the x-intercepts, you should let y equal 0. So 3x minus 4 times 0 equals negative 4. That goes away. 3x equals negative 4. Divide by 3. X equals negative 4 thirds. So what is that point? That point is negative 4 thirds, comma, 0. Alright. Let's find the y-intercept now. So to find the y-intercept, replace the x with a 0. Alright, that goes away. You have negative 4y equals negative 4. Divide by negative 4. Y equals positive 1. Therefore, that point is 0, 1, because you just plugged in a 0 for x, and y equals 1. Alright, so we can plot these 2 points to draw a line. Alright, so negative 4 thirds, 0. Now, we want to know exactly what is negative 4 thirds. So, in order to plot that point, it is best to go ahead and change it to a mixed number. So, this is the same thing as negative 1 1/3. Alright, so where is negative 1 1/3? You will go to the left to negative 1 and a third of the way. So a third of the way. So let's go ahead and plot our point here. Okay. And then we need to plot 0, 1. Where's 0, 1? Let's say this is 1. So let's go plot here. And we will draw a line, and there you go. Okay, again, since the y and x are on the same side, you can do the x and y intercepts, or you can just simply move the x to the right side. So let's do that. Let's move the x to the right side by adding x to both sides. That will cancel, and you will get y equals x plus 2. And here you have your y-intercept of 0, 2, and then you can rise, run. So what is the slope? The slope is 1. Alright. So, in order to make a fraction there, just put it over 1. Alright, so let's first plot 0, 2. Where is 0, 2? Right here. And I always notice that the y-intercept intercepts the y-axis. It will always be on the y-axis. Likewise, your x-intercept will always be on that x-axis. So 0, 2 from here, we will go up 1 unit and go to the right 1 unit because of the 1 and 1. Connect. And that's your line. So again here, this will be a good situation, since x and y are on the same side, to go ahead and find the x and y intercepts. However, what I want to show you is give you one example where you use the t-table. Okay, so in order to use the t-table, you can go ahead and put it in slope-intercept form first. So I want it in y equals mx plus b form when I use the t-table method. So what would you do to put it in slope-intercept form? You should subtract 2x first. And you will get negative 4y equals negative 2x plus 14. Then you would divide by negative 4. And you get y equals 1/2 x when you reduce 2 over 4 minus, what number can go into 14 and 4? 2. 7 over 2. Alright? In order to use the t-table here, go ahead and put your t-table, x and y, and plug in numbers for x. Alright? Since our denominators are already the same, notice we have two fractions here. But the denominators are already the same. So I don't want to get rid of the denominators in this particular case because the denominators are the same. Therefore, let's use negative 1, 0, and 1. If I plug in a negative 1, what would I get? So y equals 1/2 times negative 1 minus 7/2 is y equals negative 1/2 minus 7/2. What is negative 1 minus 7? Negative 8 over 2, which is negative 4. Let's put negative 4 here. If you plug in a 0, this is easy because this will go away. And you only have negative 7/2 left. If you plug in a positive 1, you get 1/2 minus 7/2, which is negative 6 over 2, which is negative 3. So this is how you will use a t-table, but you don't have to use it again. You could have used the x and y intercepts. Alright, so let's plot these points. First, I've noticed that I need to change this negative 7/2 to a mixed number because I need to know exactly what that is. Alright, that's negative 3 and 1/2. We're going to plot the point negative 1, negative 4 first. So this is negative 1. And let's say this was 1, 2, 3, 4. Let's just say this was negative 4. So we have negative 1, negative 4 here. Alright, we have 0, negative 3 and 1/2. So this is 0. Negative 3 and 1/2 would be here, and we have 1 and negative 3. So let's say this was positive 1 and negative 3 would be here. So you have a line like so. So notice that the line is going up to the right because our slope is. Let this special line be y equals negative 4. Now, what do we normally do to graph? We have three options again. We have x and y intercepts way, we have slope intercept form way, and we have t-table. I actually like using the t-table here. So let's do it. Now, what does y equals? Now that sounds like a silly question. What does y equal? It equals negative 4. So, under y, I can only put negative 4 because that's what y equals. Now for x, we have free range. We can plug in any number we want. I like choosing the numbers negative 1, 0, and 1. These are the points I will plot. Alright, let's plot negative 1, negative 4. Go to the left, down 4. 0, negative 4. 1, negative 4. So this special line is horizontal. So whenever you have y equals a number, you would get a horizontal line. So likewise, if you were given x equals a number, what type of special line would you get? You would get a vertical line. So if it was x equals 2, for example, if it was x equals 2, graph that. Your t-table will look something like this: 2, 2, 2, and then over here you can choose -1, 0, 1, whatever you want for y. And then your line would be a vertical line, like so. Alright, so this concludes this video presentation on graphing linear equations. I hope that it helped